That was the one that you guys said, like, it was, I had to redo it, the redo is gonna be my saving grace, and forgot. Okay, so some are different. We're moving into chapter 10 now. Logs are kind of on the back burner. I know some of you are still finishing your logs, so not a big deal. Some different functions. This is a nice, easy chapter. Okay, enjoy. So some, we're adding the functions together, and difference, guess what we're doing? We're differencing them. Okay, here's the question. What letter does that usually get replaced with? Now, that's going to come in handy later. Okay, so we're going to determine the sum of two functions. So you're given the two functions. So there's your f of x, there's your g of x. And it says determine the equation. H of x is just the combined. Just quickly on the notation, I'm going to go back into the box. It can either be written as f of x plus g of x or f plus g of x. Because we're sharing that x, so you would write it like this. You have to be okay with seeing it in both ways, and you have to know what to do with it. These two things are exactly the same thing. You do exactly the same thing. So you just got to be aware of that. So this is telling me I got to add those two things together. So my h of x, I'm going to take the equation of f of x, and I'm going to add to it the equation of g of x. Why did I put them in brackets? Right. If there were negatives, if we were doing a difference, you've got to carry that negative through the entire second one. So just keep that in mind. So the use of brackets always remind me that that's something we're going to do. They don't really matter right here. So this one's going to be x squared plus 2x plus 1. And this is h of x. You're going to lose that half mark if you named it f of x. Because f of x isn't all of this, f of x is just that part. It specifically states in the question that the new function is h of x. If you choose to name it something else, then you get deducted a half mark for introducing a new variable. Easy peasy. All right, so we're going to sketch the graph. So we're going to do f of x, we're going to sketch g of x, and then we're going to sketch h of x. So f of x, what kind of graph do you anticipate to get from that? Linear. Nope, I said f of x. Okay, so you want to have an idea of all of your functions. They should all be pretty good if I do my 5 scale. So positive 5, negative 5, negative 5. I would like to apply the majority of you here. I just marked your last quizzes from Friday, and 99, well, let's say this, 10 out of 11 people, well, 9 out of 10 people, because Caroline hasn't written yet, did their increments correctly. Labeled them. There was one person in this class who lost a half mark for not labeling their increments. That's me. Okay, so if I'm going to graph 3 functions on the same coordinate plane, what is the essential that I do once I get them all on there? I got to label them. Okay, so again, we need to get more specific. So I'm going to graph this first one. I anticipate it's going to be linear. What's the next one going to be? Parabola. Parabola. I say it that way in my head, so I can know how to spell it. What about the third one? Parabola. It's good just to do a check so you know what you're going to end up with on this graph. So if I'm going to graph this one, David, you can do a table of values, I'm going to grab my intercept. So I know it's going to cross at 1, and my slope is 2, so I'm going to go up 2 over 1, up 2 over 1. I'm going to go down 2 over 1, 2 over 1. Woo! That's probably the best straight line I've drawn all semester. So that's my f of x graph. Tables of values are going to come in handy with this. Later. Ooh, maybe we should do a table of values just for fun. We should. Yeah. You got new shoes? Proud of you. Okay, so I went from, look at this, -2, -1, 0, 1, 2. So if I were to do my coordinate pairs for this, I know when x is 0, I know y is 1. I know when x is 1, y is 3. When x is 2, y is 5. When it's -1, it's going to be -1. When it's -2, it's going to be -3. Okay, so I just substituted my x values into the f of x equation. That's 310 stuff, 310 stuff, 309 stuff. Okay, let's talk g of x. So -2, -1, 0, 1, 2. At 0, I know I'm going to be at 0. At 1, I'm going to be at 1. At 2, I'm going to be at 4. At -1, I'm at +1. At -2, I'm at +4. Now for my h of x table of values, -2, -1, 0, 1, 2. Let's do this stuff in. So -2 in here is going to be a +4, -4, 1, so this will be 1. 0. 1 will be 4, and 2 will be. I screwed that up. So 1 plus 1 plus 2 is 4. 4 and 4 and 1, 5. Okay. No. Okay. Now, the neat things with composite functions is sometimes they don't give you the equation. If I substitute 2 here, that would be 4. Plus 4. Oh. 9. Thank you. Well, mine was wrong. I don't know why I was. Thanks for noticing that. Okay, so you know what the cool thing about composite functions? If they share the x's, which our table of values do, right? -2 to +2, -2 to +2, right? So for my h of x graph, I could do this. And instead of bringing in y values here, I can take the f of x values and I can add them to the g of x values. So what is -3 plus 4? -3 plus 4. What do I get? 1. So the thing is, the x's have to be the same, right? You can't do this if they're not the same. So now I've got -1 plus 1. What do I get? 0. I have 1. You okay? Okay. I have 1 plus 0. What do I get? 1. And then I have 3 plus 1. I get 4. And then I have 5 plus 4. I get the 9. So if you're not given the equation, if they have the same x's, you can simply add their y's to get your h of x function. Now, if f of x and g of x were subtracted, guess what you would do here? You would subtract. Do some log both sides. Okay, let's graph our parabola. 0, 0, 1, 1, negative 1, negative 1, 2 and 4. This one was g of x. And this one is a parabola. We said that it was going to be a parabola. Our numbers don't actually look very parabola-ish. They don't look very parabola-ish. But I bet you if I went to negative 3, if I substituted negative 3 here, what do I get? The positive 9 minus 6 plus 1 is 4. So there's this mirror image. If I go to negative 4, what do you anticipate it to be? 9. Am I keeping you up? Maybe. Negative 2 and 1. Negative 2. Negative 2 and 1. 0, 1, 1, 1, 4. And we said negative 2 is going to be 4. Now, if you didn't, you guys can all graph parabolas, right? You can graph them in your sleep. You know how to find the vertex of this? You know how to find the vertex of this? Okay, so you need to get this tattoo. If you have this, to find the x coordinate of the vertex, it's negative b over 2a. That'll give you the x coordinate of your vertex. You could also complete the square if you want to, but I'm guessing you've given that up. If that's just gone, the knowledge, the summary is sucked out of your brain. Once you find the x coordinate, then you substitute it back in to find the y coordinate of your vertex. After you find the zeros. Okay? You need to be able to graph a parabola, like in your sleep. Sure. Yeah.
How did you get that?
How did I get one? I just put this to the front, so it's in ascending order, highest degree first.
Did you use that formula that on me?
It's telling me to take this and add it to that. So that's all I'm doing is I'm taking the actual pictures and putting it together. Okay. And then I just rearrange it so it's in order. That's all. Just so I knew it was a parabola. Yes. The graph or the table of values? It's not negative 9. It's a positive 9 at the bottom. 9 goes off my graph. I didn't graph that. Yeah. Over 1, up 4. It's not. I'm done. Done? Perfect. Okay, state the domain of range. Okay. So the nice thing is we already have the graph. So it's nice, once we have the visual, you can do the domain range really easy. So we're going to say negative infinity to positive infinity. And the range for this graph, inclusive or exclusive of 0? All right, so determine the values of f of x and g of x and h of x when x is equal to 4. So f of 4, okay, so do you know how many people solved for the letter f? Like everybody. And I don't know how to get it through to you guys, that this thing is attached. You can't break it apart. All it's saying is we're evaluating the function when x is equal to 4. Mathematically speaking, that just means I'm substituting in 4 every place I see x in that equation. So this evaluates to 9. I did that one right. So g of x, so g of 4 is equal to x squared. Again, I'm not solving for the letter g, I'm solving for that whole thing. So g of 4 is equal to 4 squared, so g of 4 is equal to 16. Now, what did I say about the table of values you could do? Add. So I could do it one of two ways. Add. Ooh, 25. There we go. I could do it that way, or I could use my formula. I can use my formula where h of 4 is equal to x squared plus 2x plus 1. So h of 4 is equal to 4 squared plus 2 times 4 plus 1. So I have 16 plus 8 plus 1. Guess what that also gives me? 25. So you could do it this way. Or if you have the equation, you can just substitute it in there. You're going to get the same answer. Easy peasy. We're done the lesson. We can go home now. All right. This is good. What am I doing with this one? Any thoughts, feelings about it? You just do it. Okay. So what am I doing? So I'm just differencing them. Well, I don't have numbers yet. What do I have? I have equations. That is ugly. I might take it one step further and do this. Okay. Oh, sorry, I wrote it. It just didn't. Right, I put it on the board and it didn't write. Sorry. All I did was distribute that negative through. That's all I did. Right? I'm not going to do anything else to it. This is it. The only thing I'm going to do is distribute that through. It's gross. It's gross. You know that that's going to show up. Like, this is going to be the stuff that shows up on your exam, and those Harvard questions that you guys copy out the back of the textbook. Like, that's the stuff that's going to know. That's the stuff that's going to be. That's the stuff that's going to be on your exam. They're not going to give you something nice that's going to be a nice, easy thing. They're going to test your knowledge here. Yeah, they're totally going to do that. They're going to go root x minus root 1 minus x plus 2, and then I can square everything. So this will give me x, and this will give me 1. I want to just throw squared around here and get rid of it. Like, the math that happens is atrocious, and it's just not magic. Like, there's no reason, rhyme, or reason to it. How do you graph this? We're just not. Okay. Terrible? Okay, there's something about, you guys did radical equations in chapter 2. You know how to deal with this. What's the domain of this function? What's the domain of this function?
It's greater than one.
Okay, so I asked for the domain of the function, you gave me the restriction. Okay, inclusive or exclusive? So the domain of this function is going to be, which is essentially what you said, Matthew, you said the restriction has to be, x has to be greater than or equal to 1. Because if I put a 0 in there, what happens? I get a greater than negative number, which I can't have. Okay, so if you have restrictions on domains in your individual functions, those restrictions will apply to each of them. Does that make sense to everybody? If I have a restriction on f of x, that restriction carries over to the combination function, the h of x. And it kind of makes sense when you're doing a table of values. What was it that they had to be with these x's? What did they have to be? They had to be the same before I could add them together. Right? Like this had to be -2, this had to be -2, and this x would have had to be -2. Well, if I don't have a -2 in this, I can't add anything to it. So those restrictions carry over. So if we do a table of values for f of x graph, where does it start? Starts at 1. So we'll go 1, 2, 3. I'm going to pick some better numbers. Okay, what's the next number I'm going to pick? If I put 2 in there, 2 is what I want to pick next. And what? If I put 3 in here, what happens? 3 minus 1 is √2, which is going to be a disaster to graph. So 5 will be next. 10 would be next. Okay? Does that make sense to everybody what we just did there? We pick numbers that are going to look nice. So if we put 1 in there, we're going to be at 0, 2 in there, 1. This will be 2, and this will be 3. Okay? Easy. Would you guys have thought to do that? Okay, so this is what you guys start thinking without a calculator. Right? Why are you confused, you know? Okay. So if I put 3 in here, what would my answer be? Square root of 2. How many of you know what the square root of 2 is in your head? Okay. How many of you know what the square root of 3 is in your head? Okay. How many of you know what the square root of 5 is in your head? Now I'm learning it, right? So what I'm suggesting you do is use strategies for when you don't have a calculator. You don't have a calculator, then you can pick some nice numbers that are going to be exactly natural. Okay, so let's do g of x. What was g of x? Oh, no. G of x was x minus 2. Any restrictions on that one? X can be anything it wants to be. It's a linear function, right? No restrictions. Right? So the domain on that one would be negative infinity to positive infinity. Right? So I can pick any numbers that I want. Am I going to? What am I going to pick? The same ones. So 1, 2, 5, and 10. So I'm going to have -1, 0, 3, and 8. even though there's no restrictions here, I'm going to use this table of values so that I can use the easy way to find my h of x. Because I am way too pretty to spend time. So the h of x graph was the root of x minus 1 minus x plus 2. I'm really too pretty to keep substituting into that formula. So because we shared the x's, 1, 2, 5, and 10, what are we going to do with the y values? I'm just going to subtract them. So 0 minus a negative 1 is going to give me positive 1. 1 minus 0 is going to give me 1. 2 minus 3 and 3 minus 8. What kind of 5? Negative 5. It's an ugly graph. It's a totally ugly graph. But we're better than that. We can do these sort of things. So now I'm going to increment on, I'm going to 10 this time. I've only got 4 points over here on the graph along. So 1 and 0. 2 and 1. 5, so there's 4, there's 5. 5 and 2. And 10 and 3. Does that look like a radical graph to you?
Yeah.
It's pretty rad. Heard it? Why wouldn't I connect it? It should be a curved line if it's a radical graph. Oh, you mean this one? I'm not to h of x yet. You would still connect all those dots because there's points in between. Curved, probably. What's wrong with my radical graph, ladies and gentlemen? There's something wrong with it. Doesn't have the bump. So let's see if I can undo this. Nice. What did I do wrong? I didn't put the bump between 0 and 1, remember? Okay, that's still not a great bump, but it's a better bump. Did you guys remember seeing that? Oh, yeah. Totally. So this one is just a linear graph. So positive 1, negative 1, positive 2 and 0, 5 and 3, and 10 and 8. I wish. Yeah, I think that would work well. Okay. Yeah. Yeah, it's fine. It's fine, but you want to have a good idea of what that graph looks like. Sometimes when you only pick 3 points, you don't get the full picture of it. You only get half of the size of parabola and stuff like that. So you want to be specific. You have to pick the correct 3 points, yeah, the ones that are going to make the biggest difference. So I'm going to have 1, 1. 1, 1, 2, 1, 5, and negative 1, and 10, and negative 5. It is gross. Hey, hey, Lavender, you're getting voted off the island. You and Kevin. Jeez Louise. Yeah. And well, did David say something wrong? Yeah, it should be a curved line, yeah. All of you. Nobody's passing this class. Except for the people who tell me my drawings are pretty. Perfect, no, perfect. Okay, so what did I say about any restrictions to F or G of X apply to H of X? So because I have a restriction on F of X, that restriction still stays true for H of X. It gets carried through. So the domain of H of X, because could I pick a point less than 1? Not here. And if there's no matching X value, then I can't add them together to get a point over here. So the domain has to have this restriction. So it would be 1 to positive infinity. What's the range? What's the range? Approximately. And why am I saying approximately? So what do we know about a radical graph? We've got this bump, right? That comes up here. And I don't quite know the value of that yet. But based on what I have here for my table of values, what do you anticipate your range being? Negative infinity to positive 1 inclusive, right? All right. So here's the situation, Matthew, where you're not given the equations. You could create the equations, a lot of people do because they find that easier. But if you get in a situation where there's no equations given and you have some graphs that you can't find the actual equation for, again, all you have to do is create that table of values. So let's quickly do our table of F of X blue. So we'll do our table of values for F of X. Okay, nice thing about this, they're two linear graphs. So their domains have no restrictions on them, so we can pick any numbers. So let's do our regular. So let's do -2, -1, 0, 1, 2. There's no restrictions, that's why I'm picking those. And then G of X, the table of values for those. And you guys don't have to do a table of values, you can actually just look at your graph and do that. But I'm going to do a table of values just so we can see how we get all of our answers. Okay, so on the blue graph, when X is -2, what's Y? -1. When, on the blue graph still, when X is -1, Y is 0. Perfect. When X is 0, what's Y? 1. Thanks, Canal. When X is 1, Y is 2. Thank you. And when X is 2, Y is, thanks. Perfect. Brilliant math. So at -2, on the red graph, we're again at -1. We're at -2, -3, -4, and -5. This is key. What are we doing? What are we doing to those two functions? We're plussing them. So because they share the X values, I can add these together. If I add -1 plus -1, I get a -2. Please don't say 0. 0 plus -2, it's going to give me a -2. 1 plus -3, -2. 2 plus -4. Are you? Woo-hoo.
only have those three. The three, zero.
All right. So exact same graph, but now what are we doing with them? Subtracting them. So because I already have the tables done, let's do that really quickly. Okay. So I'm just going to start my table here. So my x values are -2, -1, 0, 1, 2. What are my y values? 1 subtract a -1. 0. 0 minus a -2. +2. 1 minus a -3. How about +4? Okay. 6 and 8. So when I graph these, what do you anticipate? What's happening here? What are they going up by? They're going up by the lots. Okay. Good measures. Good measures. So we're at -2 and 0, -1 and +2, 0 and +4, 1 and 6. So we are going up by 2's. So this is going to be my linear function here.
Yeah.
Easy peasy, right? So a couple of things we're going to be looking for these graphs: increments, coordinates, and if you have more than one graph on one coordinate plane, you have to label each graph. I don't know if you need to put the whole equation f of x to b of x or h of x, it's fine. And you guys didn't think we were going to get through this. B. All right. So this is a systems. This is a systems thingy. Do you guys remember systems from grade 11? Systems. So you have to create two equations, and it's telling you which ones. So total cost as a function of the number of t-shirts. So this means this is going to be my y, and this is going to be my x. Okay? So it's as a function of, that means whatever letter comes after that is your independent variable. And then the next, so this is your equation 1. The next is we're doing revenue. So what's R? Is R my independent or my dependent? So revenue as a function of the number n. So n is my independent, R is my dependent. Okay? So this would be equation 2. So let's create our equation 1 from the information. This is about cost of t-shirts. So the program includes $125 fixed cost and $7.50 per t-shirt. So what's the cost of producing the t-shirts? This is linear equations from grade 9. So C equals 125, because that's your flat cost. Even if you don't produce a t-shirt, this is like designing the logo on it, costs $125. And then to produce each one, it's going to be $7.50 per t-shirt. Okay? You guys see the difference between revenue and profit? Yeah, revenue is all the money I take in before I pay my bills. profit is what I make after my markup rate. Okay, so we're trying to do an equation for revenue of the t-shirts. So revenue are, how much am I selling the t-shirts for? $12, and that's per t-shirt. So if I sell 10 t-shirts, I've taken in $120. I need to sell more than that because my cost would be higher. Okay. So let's graph these. How come I didn't give you a full coordinate plane? Okay, so which goes on the x-axis and which one goes on the y? So x is what? Is my number of t-shirts. And over here, this is going to be two different things. Cost and revenue, but they're all measured in dollars, right? So when I do a table of values, David, I'm picking on you. Should I go up by ones? Millions, wow. Point five? 0.5 is a t-shirt? I can't go above 0.5. Nobody goes up to it. I don't know. So my 10? Okay, so at 0, so I'm doing for equation 1. Let's do a quick table of values to make me feel better about life. Sorry. Okay, so if I produce no t-shirts, what's the cost of that? $125. So with 0 t-shirts, I'm at $125. If I produce 10 t-shirts, what's the cost? $20 t-shirts. I like that I'm the only one doing the math. It's not my work party today.
Are you using the 7.5?
This is the equation. I did. How do you feel about that? Does it? Okay, we can put 40 back in there and use it if we need it. So what should my x's be on this one? This. So if I sell 0 t-shirts, now what I'm going to do, if I sell 0 t-shirts, how much money have I collected? 0. 10? 20? 240. 30? 360. And 50? 600. I just got rid of it. I'm living on the lot side. Trying to do stuff. Okay. So what do you think? I think those are pretty reasonable. I'm okay with those. So this will help me, I did a table of values to help me do my increments better on the actual graph. So we're going to go up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Ooh, I could have done double that. It's okay. Okay, so dollars, what am I going to go up to? Definitely 600. So 1, 2, 3, 4, 5. Okay, that doesn't work. 1, 2, 3, 4, 5, 6. You can do that. Hey, who keeps shaking the floor? David. Canal? Probably Canal. If you want me to leave the room, like I can just leave the room. Yeah. These are by 100. Yeah, each tick is 100, and on the bottom they're 50. Okay. I create my table of values first, so that I can see what increments I need to do. Another good strategy when graphing. Don't spend your time putting increments on there that aren't going to make much sense. So let's graph this. At 0, we're at, for the blue graph, for graph 1, we're at 125. So right there. At 10, we're at 200. At 20, we are at 275. At 300, we are at 350. And at 50, we are at 500. We're not talking about 40. So this is my equation 1, right? So this one starts at 0, 0, and at 10, I'm at 120, and at 20, I'm at 240, and at 30, I'm at 360, and at 50, I'm at 600. Okay. So there was a question there. Graph the total cost of revenues on the same set of axes. What does the point of intersection represent? Your break-even point. Why is this important? So where are we going to say that that break-even point is based on our data? Where is that break-even point happening? Okay, so we're saying at 27 t-shirts, okay, so what does that mean before that? Looking at this data, what do you notice? The blue's my cost, and the red's my revenue. So if you sell anything less than 27, your cost is the upper graph, so your costs are higher than the actual revenue you're bringing in. At the break-even point, that means, so the break-even point is cost equals revenue. What's my profit at this point? 0. At your break-even point, your cost is equal to your revenue. That means you've covered your bills. You've covered all your bills. You're not going to lose money, but you're not making money either. So after 27, what happens? Your revenue becomes the higher graph. You're making a profit at that point. So profit is the difference between revenue and cost. Write a function representing P in terms of N. Okay, well, let's just stop for a second. Profit, ooh, that's an R. That's not what I want. Profit is when we take our revenue and we minus our cost from it. Right? And because write it in terms of n. You already have these equations that you created up in the first one. So you created them, and they're right here. So 12n, subtract what my cost is going to be. So I'm going to have profit is equal to 12n minus 125 plus 7.5n. So profit is equal to 12n minus 125 minus 7.5n. Can I tighten that up a little bit? I can combine like terms. So profit is equal to 4.5n minus 125. Okay? So far, that's it.